Good evening. I think we have to solve sum number 6 from exercise 4.1. Find the value of the following determinant expanding along third column. So third column means these elements. This is A13, A23, A33. Ideally, you should say D equal to A13 into its cofactor plus A23 into its cofactor plus A33 into its cofactor, or same logic, 2 into omit the row and column in which it occurs, you get this, change the sign of this, so plus 4, omit the row and column in which the element occurs, plus 0 into, actually 0 into we need not write this, but to explain how determinant is to be expanded, I have written this. So if you simplify, value of the determinant is -2. Actually, after this, we have to discuss properties of determinants. There are 5 to 6 different properties. Instead of taking that, we will discuss this simple application, which I have already done in 10th standard. In coming 2-3 days, I'll discuss all the 6 properties, and then we'll start solving sums on the same. Now, Kramer's rule. We can solve the simultaneous equations by using determinants. We can find a formula for the values of variables in terms of the determinants. This formula is known as Kramer's rule, suggested by Kramer. So what is Kramer's rule for two variables? Consider two simultaneous equations, a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Now, how to solve this? We eliminate one of the two variables. Suppose we want to eliminate y. So we multiply first equation by b2 and second equation by b1, or here they say by minus b1. So add the two equations after doing this. So what we get is this. Suppose this part is not 0, divide to get this one. Note that numerator c1b2 minus c2b1 is the value of this determinant and denominator is the value of this determinant. Okay. Now you will notice that what is denominator? It is determinant of coefficients of x and y. What is numerator? It is determinant obtained from denominator only. See, the only change is coefficients of x, which are in the first column. See, cursor a1, a2 are replaced by constant terms. See, constant terms are c1, c2. a1, a2 are coefficients of x. b1, b2 are coefficients of y. So numerator is determinant obtained from determinant in the denominator only. How? By replacing coefficients of x, which are in the first column, by constant terms. Similarly, what is y? Before that, x is denoted by dx by d. Y will be dy by d. Again, same logic. It is determinant obtained from denominator. How? By replacing coefficients of y, which are in second column, by constant terms. Okay. Yes. Now, same is the rule for three variables. Okay. These are notes. When a1 b2 minus a2 b1 is 0, that is d equal to 0, the solution of above equations do not exist. Simple. So in that case, two equations represent parallel lines. Whenever we want to solve simultaneous equations by Kramer's rule, the equations are to be written with constant terms on RHS. So Kramer's rule for equations involving three variables, we can directly write this. X is dx upon d, y is dy upon d, z is dz upon d. Can you guess what is d? Yes, it is determinant of coefficients of x, y, z. First row a1, b1, c1. Second row a2, b2, c2. Third row a3, b3, c3. What will be dx? Determinant obtained from d only. The only change is replace coefficients of x, which are in the first column, by constant terms d1, d2, d3, and so on. See this. See, this is d, this is dx. Okay. So this is how we can solve equations, simultaneous equations using Cramer's rule. Exercise 4.3, first question. Solve the following linear equations by using Cramer's rule. First one, x plus y plus z equal to 6, x minus y plus z equal to 2, x plus 2y minus z equal to 2. You have to write equations with variables on LHS, constant on RHS. D equal to, D is a determinant of coefficients of x, y, z, coefficients of x in first column, that of y in second, and that of z in third column. What is dx, or before that, what is the value? It comes out to be 4, not equal to 0. Because if this is 0, then solution does not exist. Dx is obtained from D only. How? By replacing coefficients of x which are in the first column by constant 6 to 2. So value comes out to be 4. Dy is obtained by replacing coefficients of y in D which are in second column by constants. Value comes out to be 8. What is dz? Determinant obtained from D by replacing coefficients of z which are in the third column by constants. Comes out to be 12. So by Cramer's rule, we get this. X is dx by d, 1. Y is dy by d, 2. Z is dz by d, 3. You have to write answer separately. Please check the answer. How? Put x equal to 1, y equal to 2, and z equal to 3. See whether all the three equations are satisfied or not. Now, second for homework, let me read equations. Second part. X plus y minus 2z equal to minus 10. 2x plus y minus 3z equal to minus 19. 4x plus 6y plus z equal to 2. Now third one, see, you have to be very careful. Given equations are x plus z equal to 1, but you have to write this as x plus 0y plus z equal to 1. Second equation, y plus z equal to 1, but you have to write this as 0x plus y plus z equal to 1. Third equation, x plus y equal to 4, but you have to write this as x plus y plus 0z equal to 4. Okay, you have to be very careful. So this is D. Now find out dx, dy, dz. Therefore, what is dx? Minus 4. What is dy? Minus 4. Dz 2. So by Cramer's rule, x is 2, y is 2, z is minus 1. I hope you have checked the answers. How? By putting x equal to y equal to 2 and z equal to minus 1 in all the three equations. Fourth is good one. Minus 2 upon x, minus 1 upon y, minus 3 upon z equal to 3. 2 upon x minus 3 upon y plus 1 upon z equal to minus 13. 2 upon x minus 3 upon z equal to minus 11. I hope you won't say multiply by x, y, z and so on. No. For convenience, we take 1 upon x equal to a, 1 upon y equal to b, 1 upon z equal to c. So the given equations become minus 2a minus b minus 3c is 3. Just check this. Second equation will be 2a minus 3b plus c equal to minus 13. And what about third? 2a plus 0b minus 3c equal to minus 11. Now say, find out d. Instead of dx, you will say dA, dB, dc. Find out the values. So what is d? It comes out to be minus 44, not equal to 0. What is dA? dA is written from d only by replacing coefficients of a which are in the first column by constants. Comes out to be 176. dB comes out to be minus 88. What will be DC? Yes, expand this. So it is minus 2 into 33 only. plus 1 into minus 22 plus 26. I'll directly write 4 plus 3 into 0 plus 6, that is 6. So minus double 6 plus 4 plus 18, that is minus double 4. Minus 66 plus 4 plus 18 is minus 44. So by Kramer's rule, we will not get values of x, y, z. We have to say a equal to dA upon d 176 upon minus 44 equal to minus 4. Therefore, 1 upon x is minus 4. We are interested in x. So what is x? Minus 1 upon 4. What is b? dB upon d, that is minus 88 upon minus 44, that is 2. 1 upon y equal to 2. So what is y? It is 1 upon 2. C equal to dC upon d. Minus 44 by minus 44, which is 1. So 1 upon z, because C is 1 upon z, is 1. So what is z? Z is nothing but 1. You have to write this answer separately. X minus 1 upon 4, y is half, z is 1. Second sum, the sum of three numbers is 15. If the second number is subtracted from the sum of the first and third numbers, then we get 5. When the third number is subtracted from the sum of twice the first number and the second number, we get 4. Find the three numbers. Write down. I'll dictate first part. Let the three numbers be x, y, and z. Let the three numbers be x, y, and z. From the given conditions, try to write the equations. For that, you will have to read the sum again. Sum is 15. If the second is subtracted from sum of first and third, so x plus z minus y is 5. We rearrange the terms. That is x minus y plus z equal to 5. And what is the third condition? Third number is subtracted from twice the first and twice the first plus second. Okay. So 2x plus y minus z equal to 4. Find out. So d comes out to be 6, not equal to 0. dx 18, dy 30, and what is dz? 42. So by Kramer's rule, x, y, z are 3, 5, and 7. See, while writing final answer, don't say x is 3, y is 5, z is 7. Because we have taken numbers as x, y, z, right? So we have to say that three numbers are 3, 5, 7, and in this order only. Now we discuss consistency of three equations in two variables. Consider the following three equations in two unknowns, x and y. See, three equations, not in three unknowns, three equations in two unknowns. Okay. A1x plus b1y equal to c1. A2x plus B2y equal to C2, A3x plus B3y equal to C3. If these simultaneous equations are satisfied by the same values of x and y, then these equations are said to be consistent equations. Now, the necessary condition for the equations to be consistent is, see, the necessary and sufficient is not written. The necessary condition is. Now, logic is very simple. If you remember, we have already used this in case of concurrency of three lines. We'll discuss this once this result is proved. So consider first two equations. Then we assume that these are solvable. So we know what is x and what is y, Kramer's rule. So put these values in the third equation. Because what do you mean by consistent equations? If the same values of x and y satisfy all the three. So values of x and y obtained by solving first two, we can directly put them in third equation. Cross multiply, rearrange the terms. See, actually, it is on RHS. We have to bring this to LHS. Now you will not understand this step because we haven't done properties. By interchanging C1 and C2 in first determinant, this becomes this part we'll discuss afterwards. But I can tell you that if two columns are interchanged, value changes in sign only. In fact, today only at the end of the lecture, I'll explain this property. So in short, this is arranged so that it becomes the expansion of this determinant. So this is equal to 0. So this is the condition for three equations in two unknowns to be consistent. Just a minute. Now this remark is very important. The above condition for consistency is obtained on the assumption that the given equations have a unique solution. However, this condition can be satisfied for equations which have no solutions. For example, consider the equations 2x plus 3y equal to 1, 2x plus 3y equal to 5, 2x plus 3y equal to 7. Note that these equations represent parallel lines which do not intersect. And when we solve equations, we actually obtain point of intersection. Now you will notice that if you obtain value of the determinant, if you expand this, you get 0. This means the determinant for condition of consistency is 0, but equations are not consistent. Hence, we have to ascertain whether the whether the equations have a solution or not before applying the condition of consistency. In the example, the equations given for consistency will have a common solution. Okay, now that concurrent lines, three distinct equations pairwise solvable are consistent if the same values of x and y satisfy all the three equations. Now those three equations actually represent three lines. That is why it is called as linear equations, right? Means the same point lies on all the three lines. So lines are concurrent. Okay. Third sum, examine the consistency of the following equations. First one, 2x minus y plus 3 equal to 0, 3x plus y minus 2 equal to 0, 11x plus 2y minus 3 equal to 0. Write equations with constant on RHS. Now we have to say these equations will be consistent if that determinant for condition for consistency is 0, provided. I hope you are getting this. If we try to solve first two by Kramer's rule, we observe that denominator, rather determinant of 2 minus 1, 3, 1, coefficients of x and y should not be 0. Is it 0 here? No. And that is why I have written these will be consistent if d equal to 0, provided this determinant is not 0, which is true. Now find out value of this determinant. Now d equal to this determinant comes out to be 0. So equations are consistent. Second, these are the equations. Different presentations so that we need not repeat d. So what is the value of determinant 2, 3, 1, 2? Not equal to 0, right? Then I have written now determinant for the condition of consistency is this, comes out to be -10, not equal to 0. So equations are not consistent. Third sum is for homework. Answer is consistent. Fourth one, find K if the following equations are consistent. Now the equations are to be written in standard form. 2x plus 3y equal to 2. 2x plus 4y equal to k. X minus 2y equal to minus 3k. Now these are consistent. So the determinant for condition of consistency has value 0. Expand this. Solve for k. You get k equal to 16. Second sum is similar and is for homework. Answer is k equal to 2. Now this part is important. Area of triangle and collinearity of 3 points. Theorem: if A x1 y1, B x2 y2 and C x3 y3 are the vertices of triangle ABC, then prove that its area is delta equal to half the determinant. Actually it should be modulus because determinant can be negative, right? But area is never negative. In the first column, x coordinates, second column, y coordinates, third column, 1, 1. Suppose these are the 3 vertices. Draw perpendicular segments AL, BM, CN from the 3 vertices. Clearly, OL is x1, y, because from the point A, perpendicular is drawn on x-axis. The foot is associated with x coordinate, which is x1, and so on. So OL is x1, OM is x2, ON is x3. So what is LA? LA is nothing but y coordinate, which is y1, y coordinate of A. Similarly, MB is y2 and NC is y3. What is ML? ML is x1 minus x2. What is LN? x3 minus x1. It's not at all difficult. And what is the third one? MN, it is x3 minus x2. Now this is interesting. See, area of triangle ABC equal to area trapezium ABML. See, ABML plus area trapezium CALN. CALN. Now from this sum, you have to subtract area of which trapezium? CBMN. CBMN. This is not at all difficult. See, from the rather add areas of these 2 trapeziums, this one, and from that subtract area of this trapezium so that you get area of triangle. Do we have formula for area of trapezium? Yes, it is half into sum of the lengths of parallel sides into distance between them. Use that. You have to be very careful. So half MB is y2 plus y1. LA is x1 minus x2. In fact, this is MB plus LA into ML. Okay. So y2 plus y1 into x1 minus x2 and so on. You have to simplify this patiently. You will notice, open all the brackets. You will notice that this happens to be the expansion of this determinant. So what is the area of triangle? It is half the determinant. Now the area is positive quantity. So if the value of the determinant comes out to be negative, we take its absolute value. That is modulus value. If area is given, then take both positive and negative values of the determinant for calculation of unknown coordinates. Obviously, because if value of the determinant is -4, then also we say area is half into 4. So initially we do not know when directly area is given. Now third part, simple one. If the area of triangle ABC equal to 0, then the points ABC are collinear, obviously. Because if 3 points are collinear, triangle will not be formed. So its area will be 0. Fifth one, find the area of triangle whose vertices are first, second for classwork, third for homework. Now vertices are 5, 8, 5, 0, 1, 0. Now instead of finding this, why not to find value of the determinant? Because If it is negative, in fact, in this case, it is negative, then we have to take its modulus. So value of the determinant comes out to be minus 32. So what is area? Don't forget to take half. In the next sum, we will be finding half into determinant. So if it is non-negative, we'll directly write that answer. If it is negative, we consider modulus. So what is the area here? 16 square unit. Properties of determinant. Evaluation of determinants becomes easy with the help of following properties of determinants. We'll verify these properties for determinant of order 3, which are also true for order 2. We'll just discuss first two properties maybe. The value of a determinant remains unchanged if its rows and columns are interchanged. See, consider this determinant. You will notice that its value is minus 5. Okay. Now, this determinant is obtained from this one only. How? By interchanging all the rows and columns. So first row 1, 2, 3 becomes first column. Second row becomes second column. Third row becomes third column. If you expand the determinant, you get minus 5. So the conclusion is value of the determinant remains the same even if we interchange all. The word all is important. All the rows and columns. Okay. Now the second property, if any two rows, before that, one more conclusion. From this, it is clear that we can expand a determinant with the elements in first column also. In fact, we have seen that we can expand determinant with any row or any column using that cofactor property. Not only that, the properties which are true for row will be true for column also. Okay. Now, second property, value of the determinant remains, value of the determinant changes in sign only when any two rows or columns are interchanged. I repeat the property. If we interchange any two rows or columns, value changes in sign only. See, how can you interchange first row with third column? No, any two rows or any two columns. Suppose we interchange, see what I'm writing, we interchange second and third rows. We have to write this by R23 or interchanging R2 with R3. What is the expected value of determinant? Value changes in sign. So minus 5 should become plus 5. Let us see. First row as it is. Second row will now be 3, 1, 3. And third row 2, minus 1, 2. I repeat here. Second and third rows are interchanged. So value should change in sign. So expected value is 5. Let us verify. So 1 into 2 plus 3, that is 5. Minus 2 into 0 plus 0. Yes. I hope this is clear to you. Now this is applicable for column also. The last property, and we'll stop. If any two rows or any two columns of a determinant are identical, value of the determinant becomes 0. See, 1, 2, 1. Minus 1, 2, 4. 1, 2, 1. What is your observation? First and third rows are identical. We could have taken columns identical. I have taken rows identical. So expected value equal to 0. So hereafter, when you are asked to show that value of the determinant is 0 without expanding, you have to show that any two rows or columns are identical. Let us expand. So 1 into 2 minus 8 minus 2 into minus 1 minus 4 plus 1 into minus 2 minus 2. So this is what? Minus 6. Then plus 10 minus 4. Yes. So value of the determinant equal to 0 when any two rows or columns in a determinant are identical. Somebody is asking, what about if all three rows are identical? See, if three rows are identical, two are definitely identical. So value equal to 0. So that's it for today.